We are going to look at this truss and use method of sections for solution. And with all of these videos, I know you guys probably already know this, but you could always stop the video right here to draw this picture and then restart the video. You could even try to solve it on your own and then check your work. So these videos aren't really meant just for you to turn it on and, I don't know, go cook ramen, but they should be somewhat interactive on your part in terms of either learning material or refreshing what's inside your brain that you haven't had use for a while. So this time we're going to use method of sections, and with method of sections we can solve three unknowns because we can use summing forces x, y, and summing moments. And so let's find BC, CF, and AE. Okay, so that's going to be a cut kind of through here. Now, again, with the Post-it note, I know you guys think I'm crazy, but I either need to work with the entire left side of this, everything on here, both of these forces, and nothing that's over here, or I need to work with the entire right side of this. Please don't eat my book. Okay? And so that would include these unknown reactions. So if I were to work with the right side, I would actually have to go through and find the X and Y components of D, and I would have to go through and find E using the whole free body diagram. But I like the least amount of work as possible, and so I'm kind of recognizing that if I start with just the left side, I will be able to find these internal forces without having to find reactions of the whole. So if you have a hard time with what do I draw, then cover it up. With method of joints, we used a little hair tie and we circled the joint so we could easily see what was in here. This time, what I'm going to do is anything that's exposed, I'm going to just color in a highlighter like so, okay? And you could even go ahead and put little arrows on there. And now when I go to draw, I can see exactly what needs to be included. This could hold true if you were looking at the top or the bottom, however you're looking at your cut, but you have to include everything to the left or to the right or above or below. So now I can kind of come straight back up and I can try to replicate this to the best of my abilities. And we're going to do something like this. Okay. And then I'm going to go and I cut and it's going to C. And I cut and it's also going to C. And I cut and it's going down here to E. So we can do a little dotted line showing where it would be going. And I have 5 kilonewtons and I have 4 kilonewtons. And I think, oh, let's just label A, B, F. So this is BC, this is FC, and this is AE. BC, FC, AE. So I have what I need. And again, if I go back and cover this up, I should have the exact same thing down below. Okay. If I'd started with this side, I would need this, but first I would have to find the reactions at E and D. Okay. So we can sum forces X, we can sum forces Y, and we can sum moments. And sometimes for solution, we will only use this equation, but we'll use it 3 different times. Sometimes we'll use a combination. What I need to do is I can see that 2 of these are on slopes. So I need to go back up here and figure out the slope of this line. So if I'm looking, okay, this is 3 meters, okay? This right here is 2 meters, okay? So I like to go back and look at the regular picture. So this triangle right here, I can see is 3 meters and 3 meters, so that slope is pretty easy. It's a 1 square root of 2. This one, I can go back, and I'm going to get a different color of pen this time. And if you want, we can look at it like this, or we could come down and look at it like that. So I can see that it is 1, 2, 3, 4, 5, 6 across. And maybe we just want to kind of draw that in here, 6 across. And okay, the whole thing is 5. This is 3. So that means this piece has to be 2. So it's 6, 2. And I like smaller numbers, so we can call that 1, 3, square root of 10. Okay, so we have 1, 3, square root of 10. That doesn't matter the ratio. I just divided both by 2. Okay, so now that I'm looking at this, if I sum moments about point C, it gets rid of 2 unknowns, and I'm left with just this little guy right here. Okay, if I were to sum moments about point E, I get rid of this guy, but I still have to worry about BC and FC. So I am going to start with summing moments about C, and okay, so if we're summing about C, this vector goes through C, this vector goes through C. I am left with this vector that is going towards E. So I'm going to start at C, and I'm going to kind of work my way around. Okay, positive, so I have positive 4 kilonewtons times 3 meters, okay, plus positive 5 kilonewtons times this vector line 1, 2, 3, 4, 5, 6, 6 meters. Okay. Now this vector, I don't know this perpendicular distance. That's a lot of geometry. So I'm going to walk it down here, and I'm actually going to look at right here the x and y components of AE. So the x component is going to be 3 over square root of 10. The y component is 1 over square root of 10. And the y component would go straight through C. So I'm just going to deal with this x component. It also is making positive. Plus 3 over square roots of 10 times AE. Its vertical distance from this point up is 5 meters. And all of this has to equal 0. Okay, so I'm trying to isolate AE. So we have 3 over square root of 10 times 5 times AE equals negative 12 minus 30. So that equals negative 42. So now we need to simplify. We're going to divide by 5, multiply by square root of 10, divide by 3, so we have 42. Divide by 5, divide by 3, multiply by the square root of 10, and I get that AE equals negative 8.85 kilonewtons. Okay. When I report this in my solution, we're going to call it 8.85 kilonewtons compression. Okay. We're not, because my assumption is you're going to call positive tension and negative compression, but I don't know that that's the case. So compression tension. Okay, I'm also going to note, because I don't want to call it a negative, that it's actually going in this direction. It's a compression member. Okay, so now that I have AE, let's look at BC. BC only has an X component. FC has X and Y, but it only has the Y and BC doesn't. So I'm going to start now with, we're going to sum forces in the Y direction. Up is positive. And we're going to just start here at the top. BC doesn't have that, so I have a negative 4 kilonewtons minus 5 kilonewtons. Okay, AE has a Y component. It's pushing in compression, so it's going up, plus 1 over the square root of 10 times 8.85. I'm assuming this is in tension, pulling in this direction. So the Y component is plus 1 over the square root of 2, FC equals 0. We want to isolate FC. I have a negative 9, going to add it over here. So I have 8.85 over the square root of 10 plus FC root 2 equals 9. And now we're going to pull that one over. FC over the square root of 2 equals 9 minus 8.85 over the square root of 10 equals, we have 9, 8.85, enter, 10 square root, divided by, subtract. and I get 6.20. Now I'm going to multiply both sides by the reciprocal, so it's going to be multiplied by the square root of 2, and I get 8.77 kilonewtons. It's positive. I assumed it in tension, so it is indeed in tension. Okay, now I can walk back up here, put 8.77 up on my figure, and I can clearly see that it was in tension. It's pulling this way. If I need to go back and make sure I did it correct, I can re-add -9, and these two y components both going positively should sum up to that 9. Okay, now I can sum forces in the x direction. I have an x component here. I have an x component here and an unknown. And that's how you would walk through and finish the problem. And again, when you get a solution for BC, go back and make sure that it makes sense in equilibrium. Go back and look at the whole picture, and some moments about a different point. Just pick a point like maybe right here and write an equation for summing moments about this point, and making sure that your knowns that you've solved for still hold a true statement of summing the forces or summing the moments about point F truly do equal 0. Again, you should never have a wrong answer in statics because you can always check your work.